Hi everyone, I'm Mylon Aikman, and I am back with another tutorial on how to write up t-tests in APA style. Today I'm using some t-tests that I did on some data from my anime list. I'm specifically comparing both, first off, average episode counts, and then I'm comparing the average ratings of shonen anime versus shoujo anime. First, one thing that we need to know about t-tests is here's the results of my analyses. T-tests assume that both of your groups have equal variability in your dependent variable. So this first thing here, this is a test making sure that both the shonen and shoujo anime have equal variability in the types of episode counts they're getting. And what I find here is I reject the null. What does this mean? This means that there is not equal variability in the episode count for shonen and shoujo anime, which violates the assumption of the t-test. So why do I care about this for writing things up in APA style? Well, it affects what some of the numbers are going to look like. So here's the t-test. This is looking at the number of episodes in shonen versus shoujo anime. Now you'll notice something weird about the degrees of freedom here. So here's the degrees of freedom in R's output, and you'll notice it as a decimal place. And if you've taken Intro to Stats, or if I've posted my t-test lecture, you may notice that feels a little weird, right? Normally degrees of freedom should be whole numbers. This is an independent samples t-test, so it should be the total number of anime that I have in my sample minus 2. So why is there a 0.8 there? Well, that's why we did this test here. See, if we violate the assumption that t-tests make that both groups have equal variability in the dependent variable, we have to adjust for that. If that assumption is violated, it makes it easier for us to make a type 1 error and get a false positive. So this is called a Welch correction. And what they do is they reduce the number of degrees of freedom that you have, which makes it harder for you to reject the null, which makes it harder for you to, get a false positive. That's why that is a decimal place, and that's why we did this test to see if the variability was equal. So overall, this is our output. I know you may not be using R, but just quickly to go through it, our t value is here, our degrees of freedom is here, and our p-value is here, and then we also have the means of our two groups. We also have a 95% confidence interval for the true difference in the population. Oh, sorry, you can't see what I'm doing. There we go. So how do we write this up? Well, first things first, one very important thing about writing up sentences in APA style is we need to actually say what we found. So first things first, did we reject the null? No. Our p-value is definitely greater than the typical alpha level in psychology of 0.05, so we didn't reject the null. So as a reminder, our independent variable is genre, shonen or shoujo, and our dependent variable is the number of episodes in that. So we didn't reject the null, so there was no evidence that there was any difference in the number of episodes in shonen, shoujo, and this, there's a million ways I could have phrased this. I could have written this out a million different ways, as long as I'm getting across the point that these are my two groups and there was no difference. Okay, so here comes the stats part. First things first. First, we're doing a t-test. So that means, first things first, I'm going to write a t here. This indicates this was a t-test, and I'm testing my hypothesis based on the t distribution. Now, if somebody wants to check where my critical value was, or if maybe I don't say what type of test I was doing, which you always should do, but let's say I didn't, they can at least figure out what type of test I'm doing based on the fact that that says t. Then I tell them my degrees of freedom, 2,274.80. Now, I know it only says 0.8 here, but APA style says that for most numbers, we should round them to 2 decimal places, if there are decimal places. So that's why I'm putting the 0 after it. I'm rounding this to 2 decimal places. Now, the reason we give degrees of freedom is because that tells people exactly which t distribution we were using. There's an infinite number of possible t distributions, one for every possible degrees of freedom you could have. This tells them we are using the t distribution at 2,274.8 degrees of freedom. And yep, I'm using the Welch-corrected degrees of freedom here, just to indicate there is a correction on these degrees of freedom. These are the ones that were used for the actual hypothesis test. Now I need to report my t-value. My t-value that I got is 0.19. This is a number that could theoretically be greater than 1. T-values can be greater than 1, so I put a 0 before the decimal point, and then I round it to 2 decimal places, 0.19. Now we put a comma, and then we say the p-value. P, again, it's a letter representing a statistic, so it's italicized. And APA style now currently says we should round p-values to 3 decimal places. P-values are the only thing that isn't rounded to 2 decimal places. Everything else is, p-values are 3 decimal places. Now, p-values are probabilities, so they can only be between 0 and 1. It's not possible to get a p-value greater than 1. So APA style says we don't put a 0 before that decimal place. So no 0 before the decimal place. Our p-value was 0.8471, but we round that to 3 decimals. So we get a p-value of 0.847. Now let's also report our effect size. I went ahead and I calculated Cohen's d for this. So I'm going to put another comma. And I think I'm going to have to move this up a little bit. Yep. Cohen's d, and notice the d, again, is italicized because it's a letter that represents a statistic, equals, and our Cohen's d was negative 0.006. Cohen's d can be greater than 1, so we put the 0 before the decimal place, we put the decimal, and then we round to 2 decimal places. 0.006 rounds to 0.01. So there is our APA write-up of this particular t-test. There was no evidence that there was any difference in the number of episodes in shonen and shoujo anime. A t-test with 2,274.8 degrees of freedom gave us a t-value of 0.19, our p-value was 0.847, and our effect size, Cohen's d, was negative 0.01. Okay, so that is a t-test where we were looking at a case where we violated the assumptions of the t-test. Our two groups had different levels of variability, so we had to do that Welch correction, and it wasn't significant. What if you're writing up a t-test where you didn't have to do that correction and your results were significant? So I prepared stuff for that too. Okay, so in this case, I've prepared another example for you where we don't have to deal with the problem of unequal variances, and we do not have to deal with the fact that we didn't reject the null. This time, the variances will be equal, so we don't need to do that correction, and we will reject the null. In this case, our independent variables, again, genre, is it shonen or shoujo? And our dependent variable this time is member rating. In other words, on average, what rating out of 10 were my anime list members giving to this anime? So independent variable, genre, shonen or shoujo, dependent variable, rating of the quality of the anime out of 10. Here's our test for equal variances. And if we just skip straight to the p-value, we can see that that is greater than our alpha level. It's greater than 0.05, we fail to reject the null, which means that we can treat it as if our variances are equal. We have not violated the assumption of the t-test. We don't need to do a Welch correction. Here is our t-test. Whoop, got a little ahead of myself. Here is our t-test. Once again, our independent variable is whether it's a shonen or shoujo anime. Our dependent variable is the rating out of 10 for that anime. Our t-value is 4.71 right here. Our degrees of freedom, you can see that's a whole number this time because we didn't have to do a Welch correction because we violated an assumption. We didn't violate an assumption, so we get to use a full number here. And when p-values are very small, R reports them in scientific notation. This is in scientific notation. This is definitely less than 0.05, so we absolutely reject the null. Here is the 95% confidence interval of the true difference that we would find in the population based on our calculations. And here's the mean of the shonen ratings. So on average, shonen anime got a rating of 7.05, and on average, shoujo anime got a rating of 6.88, rounding to 2 decimal places. So let's start writing our sentence. First, we need to say what we found in plain language. Remember, very important step of writing things up in APA format. If you only put it in numbers, a lot of people aren't going to understand what you're trying to say. So what we found was that on average, MAL users rated shonen anime higher than shoujo anime. We did a t-test using a t-distribution, so t on how many degrees of freedom? Well, 2,385. 2,385 degrees of freedom. The t-value that we calculated, oh, come on, yep, is 4.71. Remember, rounding to 2 decimal places. 4.71. The p-value that we got, now in this case, our p-value is very small. APA style says round p-values to 3 decimal places, but if I rounded this to 3 decimal places, it would be 0.000. That's not terribly useful. So when p-values are this small in APA style, when you can't round them to 3 decimal places because they're too small, APA style says just go to p is less than 0.001. Oh, but we can't leave it there, right? We have not reported our effect size yet, so let's report Cohen's d. Here is our Cohen's d for this effect. So I'm going to delete that period. Cohen d, again italicized, because this is a letter representing a statistic, equals, in this case, our Cohen's d is, I believe it should be the same direction as the p-values. The p-value is positive, this should be positive. I think I accidentally switched the order between doing the t-test and the Cohen's d. So I'm just going to keep it consistent and report this as positive. But our Cohen's d was 0.22, rounding to 2 decimals. There is our APA style write-up of this particular t-test. Pretty short, right? But I have told us what our independent variable is, shonen versus shoujo. I've told you what the dependent variable is, rating. And I've told you that there was a difference. Just by saying higher, that implies that there was a difference. Therefore, I'm indicating that I've rejected the null here. You don't really need to write a whole lot, and there's a bunch of different ways you can write the sentence before, like the plain words version, as long as you're conveying what your independent variable was, what your dependent variable was, and if there was a difference or not. If there was a difference, it should be clear what that difference was. In this case, I'm making it clear that shonen anime were rated higher than shoujo anime on average. I can't just say there was a difference in ratings. I need to tell people which had the higher mean, what that difference actually was. Another thing to note is the statistics part of these sentences, here and then here, they are part of the sentence. The first part of the sentence is in plain language, but you don't put a period, you put a comma. These are another part of the sentence. So make sure that you put a comma there. These aren't separate sentences. This is a sentence fragment. It doesn't stand on its own. It's just adding additional context to this. If somebody reads the sentence and they don't trust me and they want to see the numbers, I have added the numbers to the sentence so that they can see it. There we go. That's how you write up a t-test in APA format, both when you fail to reject the null and when you reject the null, and when you have to make a correction to your degrees of freedom, or when you don't have to make a correction to your degrees of freedom. That's all I have for you today. If you have any questions, comments, or concerns, please drop them in the comments section and I'll get back to you as soon as I can. Thank you so much, and I will see you next class. Bye!